Hi, and welcome to TEMEKO. In this video, we are going to get more familiar with the concept of impact of two particles. We'll learn the different phases of impact and also learn the differences between two different types of impact, which are central and oblique impact. But what is the difference between these two, you may ask? Well, the difference between central and oblique impact is that in central impact, two particles are colliding with each other in the direct direction along the line of impact that is passing through the mass centers of the particles. Whereas in oblique impact, this collision occurs at an angle with the line of impact. In this video, we are going to concentrate mainly on central impact, but the same principles that are applied in central impact are also applied in oblique impact. Okay, now that we are familiar with the actual definition of impact, let's see what really happens during the central impact of two particles. Consider that we have two particles, A and B, which are moving in the same direction with some amount of momentum, and that particle A has higher velocity than particle B. What will happen eventually? Yes, they will collide with each other. But what would happen during their impact? Well, naturally, the particles start to deform because when they collide, they exert an opposite but equal impulsive force on each other. We refer to this phase of impact as the deformation phase, which can cause the deformations of the particles to be elastic or plastic. Notice that the particles reach a common velocity v when they have experienced maximum deformation. The reason for this is that at the instant of maximum deformation, the particles are not moving relative to each other anymore. In the following restitution phase, when the particles start to separate from each other by the opposite but equal restitution impulse, the particles will begin forming back into their original shape. Note, however, that if the particle experienced earlier plastic deformation, the particle would remain permanently deformed. It is also good to know that in reality, restitution impulse is always smaller than deformation impulse, which causes the situation that the particles do not usually separate completely after impact. But we can idealize this and consider that they will be. In this case, the velocity of particle B will be higher just after the impact than particle A's velocity. Let's move on now to discuss about something that may be perhaps the most important thing in this lecture video, which is the coefficient of restitution. It's important for us to understand it because it's something that we use as a tool to solve problems related to impact. If we apply the principle of impulse and momentum for particle A during its deformation and restitution and determine the relation of both the impulses, we obtain the following expression for our coefficient of restitution. Similarly, we could also express coefficient of restitution in case of particle B as follows. If we then eliminate V from both equations, the equation for coefficient of restitution will finally become. This equation defines the ratio of the relative separation velocity of the particles just after the impact to the relative approach velocity of the particles before the impact. Most often, we use coefficient of restitution to solve the final velocities of the particles after their separation, when we have knowledge about their initial velocities. Be aware that the magnitude range of coefficient of restitution can be between 0 and 1. And it has been proven experimentally that the magnitude is dependent on the collision speed, and also on the size and shape of the colliding objects. Notice also that if the magnitude of coefficient of restitution is 1, then the impulses of the deformation phase and restitution phase are equal, and the kinetic energy of the system has been conserved completely. But as we have learned earlier, this is rarely the case, because in real life, perfect elastic collisions don't exist. On the other hand, if the magnitude of the coefficient were 0, then the particles would remain stuck to each other while they move with equal velocity after the collision. Hopefully by watching this video, you know what is meant by impact, and you are also familiar with the different phases of central impact. You also know the definition of coefficient of restitution and how it can be applied. Thanks for watching and have a nice day.